once I have the formula for this tangent line, the next thing that I did in my picture was to find where that tangent line intersects the x-axis. Well, that's pretty fancy, but all I'm really asking is, what's the zero of that tangent line? Every linear function is just a polynomial of degree 1, right? Y equals mx plus b. So I should be looking for the x-intercept. Well, simple enough. That means that my y is going to be 0. So let's say that x2 is going to be the x-coordinate where this line crosses the x-axis. And then that's also going to be my second guess for the location of this root. Then my x2, I can just rewrite this equation. As long as this derivative is not equal to 0, then we can solve this equation. Why do we not want the derivative equal to 0? Because when I solve for x2, I need to divide by f prime of x1. So this will not work if the derivative is equal to 0, just from algebra. But in terms of the picture, if I've got some function with a horizontal tangent line, and I'm supposed to follow that tangent line until it hits the x-axis, a little hard to aim there, never going to happen if my tangent line is horizontal. So I have a geometric reason as to why I can't have the derivative be 0, or rather why this method will not work if the derivative of the function is 0 there. And I have an algebraic reason as well. So I like to think of this as algebra and geometry complement one another. They tell us the same information in different perspectives. There's an algebraic reason, I can't divide by 0. There's a geometric reason, two horizontal lines do not cross each other. Okay, so as long as my function is amenable, and what do I mean by that? As long as my function does not have a derivative of 0 here, then I can use this new formula to improve my guess. So what am I going to do? I'm going to replace my old guess, x1, by subtracting off the value of the function, f of x1, divided by the derivative of the function, f prime at x1. So I'll have some real number x, and this formula gives me my new, guess. Then I get to do it again. So each time that I do this, as long as it's working, should be getting me closer to that root. So maybe my initial guess is here at x1. I find where that function is, right? I find what my y coordinate is. That's just the function f applied to my guess. I find the derivative there. Using this information, using the derivative, I take my second guess to be x2. That'll be closer. It might not be exactly equal to that root, so I'll have to use the formula again to find my x3. And once again, my x3 follows this formula. Each successive guess is the old guess minus the value of the function at the old guess divided by the value of the derivative of the function at the old guess. So this is our method. We are going to keep repeating this process until we get close enough to the root.